Welcome to Mr. Rafa Online Tuitions. Please don't forget to subscribe to my YouTube channel, Mr. Rafa Online Tuitions, for more videos. Are you writing the exams this year, 2024? Please don't forget to contact me. I can help you so that you can achieve your dreams in this year's exams. I'm here to crack the codes of physics. So the first topic that we are going to look at is moments. So this is a pamphlet that I made for you. If you are interested in this pamphlet, contact me, WhatsApp me, pamphlet. All the questions that they can ask you about moments, they are in this pamphlet. So please follow me as we look at the first party of moments. Question 1A, define a moment and state its SI unity. So what is a moment, or define a moment? A moment, it is the turning effect of a force about a point called a pivot. A moment, it is the turning effect of a force about a pivot. About a pivot. That is what we call a moment. In other words, we are saying a moment is the effect that a force has on an object, causing it to turn. That is a simple language that we can use for a moment. A moment, it is the turning effect of a force about a point which is called a pivot. Or in simple terms, I can say a moment is the effect that a force has on an object, causing it to do what? To turn. That is what we call a moment. Then they have also said state its SI unity. So the unity for a moment is calculated in Newton meters. Then the symbol, it is capital letter N, small letter m. Remember that Newton, it is the name of a person, Sir Isaac Newton. So when you are writing its symbol, it must be in capital letter. Okay, so this is a symbol. This is its SI unity. So this is the SI unity. This is the symbol of the SI unity. Part B, give two applications of a moment. Number one, a seesaw. A seesaw is the everyday life example of a moment. So seesaws. A spanner turning around a nut. It is another example of a moment. A spanner turning around a nut. Another example that I can give you, it is simply a crowbar. A crowbar. You can add your own examples. So we have another example, opening and closing a door. Opening and closing a door is another example. So opening and closing a door. That is another application of a moment. So a scissors as well. A scissors is another example of a moment. It has the turning effect on it. Okay. Part C. Is a moment a scalar quantity or a vector quantity? Give a reason for your answer. Is moment a scalar quantity or a vector quantity? Give a reason for your answer. So a moment is a vector quantity. A moment is a vector quantity. Give a reason for your answer. Before I give you a reason, what is a scalar quantity and what is a vector quantity? When we talk about a scalar quantity, this is a quantity that has only a magnitude, but it has no direction. Okay, let me first explain a little bit about a scalar quantity and a vector quantity. So when we talk about a scalar quantity, it is simply the quantity. It is the quantity that has only the magnitude, but has no direction. So that is what we call a scalar quantity. So a scalar quantity, it is simply the quantity that has only the magnitude. Magnitude, it means the size, but has no direction. We can give an example of mass, e.g. mass. Mass, it has only a magnitude, but it has no direction. For example, a 25 kg of meal, it has 25, it is the size. 25, it's a size. So 25 kg of meal. So you cannot say that 25 kg of meal going to the north. So a scalar quantity is a quantity that has only the magnitude, but it has no direction. Example, mass. When we talk about a vector quantity, there is a quantity that has both magnitude and direction. It is the quantity that has both magnitude and direction. So example, it's a moment. It's a moment. So a moment is a vector quantity. It has the size and it has a direction. Is it going to the north or to the south? Is it clockwise or anti-clockwise? So a moment is a vector quantity. So what is the reason? Because it has the magnitude and the direction. We go back to the question. Is moment a scalar quantity or a vector quantity? Give a reason for your answer. So we are saying a moment is a vector quantity. So what is the reason? The reason is that it has both magnitude and direction. So that is the reason. Okay, part 2. Calculate the moment of the force and state the direction in which it acts for each of the following. So A, the question is calculate the moment of the force. So remember what we said. We said that a moment is a turning effect of a force about a point called a pivot. So mathematically, a moment can be expressed as force times the perpendicular distance from the center of the force to the pivot in the line of action. So mathematically, moment is equal to force times the perpendicular distance from the center. Mark that one, mark that chord. From the center of the force to the what? To the pivot in the line of action. So remember the unity for a moment, it's Newton meters. So remember that your force is in newtons and your distance in meters. So in this case, we are looking for a moment. So force is given, it is 5 newtons. Then perpendicular distance is 0.5 meters. So moment is equal to force is 5 times distance 0.5. So moment is equal to 5 times 0.5. We have 2.5. So the moment is 2.5 Newton meter. So that is the first question. And state the direction in which it acts. So the direction in which it acts, it is clockwise. The direction it is clockwise. So direction, the direction in which it acts is clockwise. That is the direction in which it acts. So the direction in which it acts is clockwise. So moment is equal to force times the perpendicular distance from the center of the force to the pivot. So in this case, force have not been given. What have been given, it is mass. Distance, it is in centimeters. So what we are going to do is we are going to convert this 400 grams, you convert it to force. So how do you convert mass to force? You use this formula, weight is equal to mass times gravity. So weight is equal to mass is in grams. So it must be converted to kilogram. Very important. So you say 400 grams divided by 1000. So why 1000? The reason why I'm dividing with 1000, I'm converting from grams to kilogram. Then times gravity. So gravity is 10. So 400 divided by 1000 is going to give me 0.4. So 0.4 times 10. So 0.4 times 10, it is 4 newtons. It is 4 newtons. So 400 grams is equal to 4 newtons. So that is my force. So moment is equal to 4 newtons times distance. So remember the unity for a moment, it is Newton meters. So I'm going to change 25 centimeters to meters. So my distance is 25 centimeters. So how do we change? So distance, it is 25 centimeters. To convert to meters, you divide by 100. So remember that 1 meter is equal to 100 centimeters. So in this case, it is 0.25 meters. So that is how we convert. So in this case, we have 0.25. So moment is equal to 4 times 0.25. We are going to have 4 times 0.25. It is 1. So the answer is 1 Newton. Now the direction in which it acts, it is the anti-clockwise moment. Anti-clockwise moment. So this is anti-clockwise moment. So clockwise, this is clockwise, this is anti-clockwise. So anti-clockwise, clockwise. So this is anti-clockwise direction. I hope you are enjoying what I'm doing. Don't forget to subscribe to my YouTube channel, Mr. Rafa Online Tuitions. Don't forget to share the video. Share the video, share the video, share the video. Let's see. Moment is equal to force times distance. Force times distance. So moment is equal to force. The force acting on this body is 4 newtons. So 4 newtons times the perpendicular distance. So the perpendicular distance is 40 centimeters. Okay, let me take you back. On this one, it is 1 Newton meter. 1 Newton meter. Good. Okay, so 4 times this distance, it is in centimeters, so it must be converted to meters. So how do you convert? You can even say 40 divided by 100. So why 100? There we are converting from centimeters to meters. So moment is equal to 4 times 40 divided by 100. It is 0.4. So moment is equal to 4 times 0.4. So 4 times 0.4, the answer is 1.6. So 1.6 Newton meter. The direction in which it is acting, it is anti-clockwise. Anti-clockwise. So this is anti-clockwise and this is clockwise. So clockwise, clockwise. Okay, this is clockwise, this is anti-clockwise. So the direction is anti-clockwise. So this is our first party. So please don't forget to subscribe to my YouTube channel, Mr. Rafa Online Tuitions. So we are cracking the codes of physics, and our topic for today is moments. So our next step, it will be now principle of a moment. So principle of the moment. So that is our next step. That is our next step. So our next step will be principle of moments, or the calculations. So we have various examples. So examples. So those are examples. So we have exam questions as examples in that case. And then we have the exam material. So that is the exam material. So don't forget to subscribe to the YouTube channel. So that is the pamphlet. That is the pamphlet. If you want this pamphlet, please, you can contact me, you can WhatsApp me, and I'll send you this pamphlet with answers. Don't forget to share the video. Don't forget to subscribe to the YouTube channel. That is the YouTube channel, Mr. Rafa Online Tuitions, okay? Or the Facebook page, Mr. Rafa Online Tuitions. And these are my contacts. Don't forget to subscribe to the YouTube channel. So these are questions. Exam material. Don't forget. These are exam materials. All these, I have the solutions. All these, I have the solutions. Don't forget to subscribe to the YouTube channel, Mr. Rafa Online Tuitions. My name's Angel Chanda, popularly known as Mr. Rafa. See you on the next episode of Moments.